What is triclosan? First made as a pesticide, triclosan has been around since the 1960s. In recent years, it made its way into a wide range of personal care items. Triclosan is best known for its germ-killing power. That's why it has been used in so many hand soaps and body washes. In water-based products like aftershave and makeup, it is a preservative. It also helps fight odor, which is why it's in deodorants and body sprays. Your toothpaste might have triclosan, too. Colgate Total is the only American Dental Association approved toothpaste with this ingredient. The FDA approved it after reviewing data showing that it prevents gum disease. Triclosan, TCS, is an antimicrobial used so ubiquitously that 75% of the USA population is likely exposed to this compound via consumer goods and personal care products. In September 2016, TCS was banned from soap products following a risk assessment by the USA Food and Drug Administration, FDA. However, TCS still remains, at high concentrations, in other personal care products such as toothpaste, mouthwash, hand sanitizer, and surgical soaps. Triclosan is readily absorbed into human skin and oral mucosa and found in various human tissues and fluids. Since the invention of antimicrobial chemicals in the mid-1900s, their incorporation into a multitude of consumer products has significantly increased. Most of these chemicals are added to consumer products in the absence of a fully encompassed toxicological profile. Triclosan, TCS, is an antimicrobial that had its original use in hospital settings in 1972. Since then, it has been incorporated into a variety of consumer products including soaps, hand sanitizers, toothpaste, and mouthwash. In 1977, TCS production, covered by the United States Toxic Substances Control Act, was between 0.5 and 1 million pounds per year. This production increased to 1 to 10 million pounds in 1998. Estimated global production of TCS in 2011 was 14 million pounds, which decreased to 10.5 million pounds in 2015. Between 1999 and 2000, 75% of 178 liquid soaps sampled contained TCS and 30% of over 300 samples of bar soaps contained TCS. In the late 2000s, 2008 to 2010, TCS as an active ingredient was found in 93% of liquid, gel, or foam soaps, FDA 2013. Consumer products containing antimicrobial active ingredients totaled $886 million in total sales, FDA 2013. TCS containing products at concentrations ranging from 3.5 to 17 and were sold at the rate of 278 million 16 ounces units between September 2008 and 2009. It resulted in annual consumption of 132 million liters, FDA 2013. History of triclosan. When triclosan, which has the chemical name 5-chloro-22,4-diphenoxyphenol, it was originally developed about 20 years ago, it was believed to be a non-ionic broad-spectrum antimicrobial agent with a favorable safety profile. As a result, this chemical was rapidly incorporated into many different personal care products. They include deodorant soaps, antiperspirants, shower gels, antibacterial hand soaps and soap bars, dishwashing liquids and toothpaste. Most of these personal care products will contain anywhere from 0.1% to 0.3% of triclosan. Consumer products. Triclosan has also been incorporated into other consumer products like kitchen utensils, children's toys, bedding, clothes, fabrics and trash bags that are not regulated by the FDA. Shortly after its introduction into commercial products in 1998, approximately 1,500 tons of triclosan were produced, out of which 350 and 450 tons were distributed throughout Europe and the United States, respectively. Triclosan's mechanism of action. The antimicrobial activity of triclosan has been shown to inhibit the growth of several different types of bacterial and fungal species. It inhibits the growth of the AP-complex of parasite species Plasmodium falciparum, which causes cerebral malaria, and Toxoplasma gondii, the causative agent of toxoplasmosis. Toxoplasma gondii, protozoan which is transmitted from cats and other animals and causes toxoplasmosis, especially dangerous for pregnant women. When used at low concentrations, triclosan can successfully inhibit the growth of microorganisms. However, higher concentrations of this chemical will directly kill microorganisms. Triclosan functions as an antimicrobial agent by impairing the production of bacterial lipids. More specifically, it blocks the active site of a bacterial enzyme known as an elacyl carrier protein reductase. Since humans like this enzyme, triclosan has been generally accepted as harmless to human health. What's the downside? Because triclosan acts like an antibiotic, its widespread use might be part of the reason that common bacteria are becoming harder to treat. It is of concern that triclosan is getting into the water and is toxic to aquatic animals. The triclosan in your soap and other personal products is unlikely to be a problem in the short term. But some early research suggests that in the long run, it might affect your hormones. It prompts cancer cells, such as breast cancer, to grow. Triclosan makes it easier for antibiotic-resistant bacteria, like MRSA, to grow in your nose or throat. Some studies of triclosan have looked at possible effects in people. For example, Aiello and her colleagues found that those with the highest concentration of it in their urine were more likely to have allergies. That doesn't prove that triclosan was to blame, though. Interestingly, DCS-containing soap products were not found to provide any additional skin sanitizing benefits compared to soap not containing TCS. In addition, DCS was found to produce bacterial resistance via target site modification, which decreased the inhibitory effect of this chemical. Bacteria in the environment may also become TCS resistant following environmentally relevant exposure levels. Bacteria in the microbiome might be altered due to TCS. TCS exposure might also result in bacterial resistance to other antimicrobials. Increased TCS resistance is also associated with an elevation in resistance to multiple other antibiotics in clinical settings. In September 2016, TCS was banned by the FDA in soap products, liquid, gel, foam, bar. However, TCS still remains allowed in toothpaste, hand sanitizer, and mouthwash. Ban. The European Union, EU, banned TCS from all human hygiene biocidal products starting January 2017. TCS is widely utilized in toothpaste as this agent helps fight gingivitis, inflammation of the gums. Colgate Total Toothpaste, containing 10 TCS, was the number 2 leading toothpaste in sales in 2016. TCS also remains in use in hand sanitizer products within the healthcare field, postulated to be beneficial due to hand sanitizers' enhancement of hand washing compliance. Based upon these statistics, consumers are clearly being exposed to TCS at high concentrations. Researchers studying the stomach bug Escherichia coli in the lab found that triclosan could cause antibiotic resistance via a phenomenon known as cross-resistance. Cross-resistance is a term used to describe how exposure to one substance can cause bacteria to become immune to a similar substance that it hasn't encountered before. Researchers discovered that bacteria exposed to triclosan may also evolve resistance to quinolones. Quinolones kill bacteria by targeting a chemical involved with deoxyribonucleic acid, DNA, or genetic material replication. When a bacterial cell divides into two, a copy of its DNA is made to pass on to the new daughter cell. Quinolones stop DNA from being replicated, which causes the bacteria to cease dividing and die off. But the researchers found that bacteria are able to evolve special defenses to resist attack by quinolones. Bugs can evade the antibiotics by evolving new mutations which stop quinolones from destroying its DNA. And these mutations also make the bacteria resistant to treatment with triclosan, the researchers found. Researchers warned that the phenomenon may also happen in reverse, with exposure to triclosan causing bacteria to evolve mutations which can protect them against quinolones. Dr. Mark Weber, of the Institute of Food Research at the University of Birmingham, said, "The worry is that this might happen in reverse and triclosan exposure might encourage growth of antibiotic-resistant strains. We found this can happen in E. coli. As we run out of effective drugs, understanding how antibiotic resistance can happen and under what conditions is crucial to stopping selection of more resistant bacteria." The World Health Organization has previously warned that antibiotic resistance is one of the biggest threats to global health. Co-author Professor Laura Pittock, of the Institute of Microbiology and Infection at the University of Birmingham, said, "The link between quinolone and triclosan resistance is important as triclosan has become ubiquitous in the environment and even human tissues in the last 20 years. Given the prevalence of triclosan and other antimicrobials in the environment, a greater understanding of the impact they can have on bacteria and how exposure to these antimicrobials may impact the selection and spread of clinically relevant antibiotic resistance is needed." However, DCS effects on human and environmental health are still currently under debate. Data are also presented on comparisons of DCS levels in tissues. They are relevant because DCS-containing products are typically utilized by consumers by direct application to human tissues. This review summarizes the literature on DCS exposure levels in humans and animals, DCS metabolism, occurrence of DCS, its breakdown products, and the health effects of this chemical. Exposure. DCS exposure likely occurs primarily via consumer products that contain DCS. Environmental exposure may also occur through water and/or animal food products contaminated with DCS. Measurable levels of DCS are present in milk and blood of nursing mothers and human urine. DCS was detected in 75% of the U.S. population between 2003 and 2004 with urine concentrations ranging from 7.9 nm, 13.1 micrometers. A 2014 study in Quebec City identified DCS in 44 of the 46 human urine samples. A recent study in China showed that 80% of 209 participants tested displayed detectable levels of DCS in their urine. In Queensland, Australia, Heffernan et al., 2015, conducted between 2012 and 2013 and found that DCS was detected in all 2,400 urine samples with concentrations ranging from 0.08 to 0.71 micrometers. In many of these investigations, females tended to exhibit higher DCS concentrations than males, and the age group with the highest DCS concentrations tended to be in the 20s. Weiss et al., 2015, in Canada noted DCS in 87% of urine samples from 80 healthy pregnant women. Between 2007 and 2009, a study of expecting mothers in New York found TCS in 100% of the 181 samples and TCS in cord blood from the neonate in 51% of the samples. These results indicate that consumers around the world are exposed to TCS, and TCS is readily absorbed into the body. Body burdens of DCS differ greatly depending upon the 1. Site being measured such as skin, blood or urine, 2. Concentration of exposure, and 3. Type of exposure. After use of mouth rinses or dentifrices that contain TCS, plasma levels of TCS increase rapidly. The above studies demonstrated absorption and retention of DCS following dermal and oral absorption and retention, while other studies reviewed below illustrate the ability of DCS to disrupt biological processes. It is noteworthy that the urine concentration is an indirect indicator of DCS levels in the tissue. Overall, TCS was detected in humans globally in an assortment of tissue samples such as blood, urine, and variety of different tissue types. TCS was also retained in the body with a half-life of 21 hours, showing that even a brief use of a TCS-containing consumer product may result in a prolonged exposure of multiple hours. Due to TCS' ability to penetrate and remain in tissues, the tissue antimicrobial concentration is sufficiently high to induce harmful effects to humans. Within just the last few years, the literature on TCS-mediated adverse health effects has expanded from virtually non-existent to quite robust. This section discusses these effects along with related studies in animals and in cell culture which lend support to these epidemiological findings. TCS also induced a multitude of effects on cellular function and molecular pathways. DCS is also associated with cancer development. DCS was reported to decrease cardiovascular functions in mice with 12.5 and 25 mg/kg concentrations. This antimicrobial also impairs muscle function in both mice and fathead minnows assessed via grip strength and swimming performance, respectively. The molecular mechanism underlying this impairment is postulated to be related to TCS effects on calcium signaling in cardiac and skeletal muscle cells. Recent human epidemiological studies correlated DCS with reproductive and developmental defects. Several investigators showed an association between high TCS urine levels and diminished head circumference in boys. Enhanced TCS sera levels obtained from human mothers was associated with birth defects. Several studies showed that TCS exhibited endocrine-disrupting effects. It may account for a portion of the adverse reproductive outcomes observed in the epidemiological studies. Adverse effects. Mitochondrial disruption by antimicrobial may also contribute to adverse reproductive effects, as proper mitochondrial function is required for embryonic development. Similar reproductive adverse effects were also reported in animal studies. An association between high TCS concentrations and spontaneous abortion was shown in mice. Treatment with TCS on certain gestational days decreased implantation rates in mice. An increase in spontaneous abortion rates occurred in pregnant rats exposed to TCS, and the placenta was found to accumulate compound after treatment. In the human and the animal studies, there is no apparent molecular explanation provided for the observed effects of TCS at the organismal level. Several human epidemiological studies noted associations between TCS exposure and allergies and asthma. Urinary TCS concentrations were correlated with increased allergies diagnoses in the under 18 age group. An elevated level of TCS may lead to an enhanced risk of asthma, allergies, and food sensitization. In addition, Hong et al., 2014, suggested an association between a high use of antimicrobial products with wheezing and allergic rhinitis. Several animal and in vitro studies with respect to the immune system show similar results. Conclusions. TCS was recently been banned by the FDA, but only from certain soap products. This antimicrobial still remains in many consumer products, including popular toothpaste. There remains some controversy regarding whether TCS concentrations absorbed into the human body might induce adverse effects noted in lab studies. Comparison was made of TCS levels absorbed into human skin to compound concentrations reported to produce adverse effects. It was found that antimicrobial levels absorbed via the skin are comparable to those needed to induce effects seen in lab studies such as mitochondrial dysfunction. It is also important to note that TCS is not rapidly metabolized dermally, and the majority remains as the parent compound for at least 24 hours. Several studies demonstrated TCS-mediated effects following just a few hours following chemical exposure. TCS might undergo both biotic and abiotic transformation, leading to production of a multitude of byproducts. Many of these byproducts have not been thoroughly investigated, while others were found to be more toxic than parent TCS compound. TCS was reported to be an endocrine-disrupting chemical in multiple species. TCS might also affect immune responses, ROS production, and cardiovascular functions. There has been a recent increase in the number of epidemiology studies examining TCS with effects. Many of these studies observed an association between a rise in TCS exposure and reproductive and developmental defects in infants. Taking into consideration these significant findings, incorporation of this antimicrobial into readily available consumer products, not just in soap, needs to be re-evaluated, and biological effects of its breakdown products and metabolites need to be investigated. For several decades, researchers have become increasingly concerned by the contribution disinfectant agents make to the rise in global bacterial resistance. As the threat of antibiotic resistance increases, it is important to consider which antimicrobial products, if any, used and how it may impact our health and others. In order to further preserve public health, federal agencies have a responsibility to monitor companies that simply replace chemicals like triclosan. They need to be replaced with safer products and not that still have a documented history of promoting cross-resistance to antibiotics.